Hey everybody, Adam Savage and Norm Chin in my cave, and we have just logged 100 hours of printing with the Fuse 1 SLS.
Yes, it's been about a month since we got it integrated. I thought it'd be a good time to do a check-in since there were so many comments and feedback, both from people curious about the machine as well as experienced users of Nylon printing who reached out.
Several people who actually work with and run Fuse machines offered some fantastic advice. We really appreciate all the comments. Like, this feels like a collaborative effort, frankly, and we really appreciate that. And we have learned a lot in the last month.
Well, I think one of the biggest takeaways with 100 hours of printing, we're learning that we like using the machine.
Yeah.
You know, so often we bring a machine that requires infrastructure, multi-tiers of processing, and it's daunting even though the finished product might be good.
Yeah.
But momentum can be broken in any of those steps.
And every process requires post-process finishing. You're either snapping out the supports and sanding your filament printer, or you're washing and drying your resin parts, or you're sandblasting and scrubbing these guys. There's no way to avoid it. But frankly, for the post-processing, this has rapidly become my favorite engineering solution 3D printer.
Yeah. I think both the amount of work actually required is less than expected, and the quality of materials is better than expected.
Yes.
And that balance makes it really fun to send prints here.
I totally agree. We've been getting some details out that are really spectacular, but I've been printing out some stuff for engineering that has been absolutely like, I've started to get really excited. I've said years ago, I hadn't figured out yet what 3D printing brought to my personal process. Now, not only have I been learning what it brings to the process, but each new process brings a whole new kind of set of skills, a set of ways to think through engineering.
And you'll see these prints pop up on your builds in the weeks and months to come. Some we're not unveiling right now. I thought it'd be fun to take a look at some prints that we did just to get our, get our reps in and the things we learned.
I think that one thing I think is really funny is you're always trying to maximize your printer. You're always trying to get as many parts into the volume as you can, and that's non-trivial with each of the processes. It's maybe the easiest with this one.
One button. Like, I really love the art of generating supports on an SLA printer.
Right, yeah.
And there's a balance to it. I like the
philosophy of how you set stuff to get a good print without support. Yeah.
It tells me how much I understand the process and the machine, right? Every machine can be different. Here there's tuning, but I'm pressing a pack button.
Well,
and
also
it's packing it all together.
The machine works best when you're using a certain amount of material per print, and so you're adding a lot of the stuff here on this table. You have been adding to prints that we've been doing to fill in the volume and also to experiment.
Yeah. I want to start off with some print in place flexi models, because our first failed print was a mechanical joint, right?
Yeah.
Like, we couldn't actually push ball joints in because the tolerances were too tight.
We scaled them way up, and the tolerances did not scale.
Like, there was no flex in the nylon. And a lot of you out there suggested, well, why didn't we, in the software, just align the joints so that they would print in place? I think theoretically that's a sound idea.
It's a reasonable suggestion.
It would require recading the models to allow for the tolerances, and then you might lose the friction needed for a movable joint because you don't want it necessarily to be just like a puppet that's completely flexible.
I'll go further. I downloaded and printed up a prop model from Thingiverse, and one of the issues that the person who drew it said is I didn't include any allowances. Everything is drawn exactly. Yeah. And as I got the prints out of here, they were so dimensionally stable that it really was like within 1,000th of an inch, and everything was a press fit. So for stuff like that, there's a lot of tuning you can learn to do in the drawing to make that work.
And the thing I learned quickly was when there are parts are really close together, whether it's by design or because you've actually pressed them together, the way the laser heats up the nylon, they can become actually fused together. That you want to have a little bit of space, that millimeter, 2 millimeter space, because when they're too close, that extra armor layer that's generated and it actually binds it in a way where I've downloaded some print in place like mechanical parts, like geared parts that don't work out of the fuse. because tolerances are too tight. They actually have now turned to one monolithic piece.
Right.
The other thing was, if you do print and you have like a flexible joint, can we hog out? Can we get that negative
can you
space
get
back?
to the material?
Can we reclaim it? And it turns out you can. Like here's a flexi print, and there's there's a little space here where you wouldn't have to worry about that negative space in a resin print or an FDM print.
Right.
FDM print wouldn't have it. But you can see, like even as you're moving it, there's powder trapped in there, right? And when this came out of the printer, it was solid as a stick.
Oh, you must have been like, oh, fail.
But adding a little pressure and putting under the blast, shooting the glass beads inside, it actually frees it up. And now you get full range of movement.
And I want to address something that I was wondering before the Fuse showed up. You might be wondering, why 3 machines? Why 1 for printing and 2 for post-processing? And the answer is, the main reason you scrub before the sandblasting is so that you can recycle the bulk of the material. We've been told you lose between 5 and 10% just in the normal cleaning, and you want to reduce that as much as possible. And then with the sandblaster with glass beads, it is impossible to overstate the import of that step. It is, I was firing glass beads directly at incredibly gentle structures, and nothing else was getting rid of that powder. Not scrubbing, not air. It was the glass beads were critical.
And doing it by hand or through the tumbling method.
Yep.
I mean, you have surfaces here where with just that extra bit of time, you can see just the actual finish. That looks like, it looks good, but it's not as clean as a little bit of sparkle in that nylon.
And this is one tiny issue I'm having with the glass bead blaster is ability to have sensitivity of my holding and reconfiguring. That's just a little bit, is taking me some learning. But again, like you get up close and you hit this thing with glass beads, like I was in here, the interior of that is hollow, and I was just firing glass beads in that, watching powder pour out. And I had worked on it with a pick before.
I look at a skull model like that, and I imagine how tough that would be to print in either SLA or FDM.
Exactly.
You would have supports on the inside.
Oh, and stuff like this?
Yes, that
it
delicate
would never work for you. You'd be snapping those out with the supports. That's a classic. And I want to show you a really remarkable one, because you printed the Raven skull, both the separated and together. And separated, take a look at this.
Oh, they perfectly line up.
They almost perfectly line up with just a little, I mean.
Yeah, okay.
That's kind of amazing. Both the dimensional fidelity, but also that, like, I pulled these out of Sandblaster and they're all extant. Yeah. That's amazing.
And that's not a ton of mass either.
No.
Which is really fun, because you're not printing, it's like a skull like this, it's mostly hollow.
Yeah, what did you say? This was like 200 grams?
Yeah. Which, not a lot, which is why we want to pack. Like, I was so worried about, hollowing out models.
Yeah.
At this point, I'm printing this solid because it's not that many more grams.
Really?
Yeah.
It also, I want to talk about how these prints feel and sound unlike any other process. They almost sound ceramic when they tink against each other. And speaking of printing solid, we did a I've been holding on to this model for a while. It is, as far as I can tell, incredibly accurate to, we'll include a link to this, but this is incredibly accurate to the sculpture in Dune.
Yeah, the House Atreides.
The House Atreides, the bull, their symbol of their house. This printed up just beautifully, and a little bit of warpage.
Yes. I was curious whether it was in the model or not. It's not in the model. This was oriented, it's one of the larger things we printed. It's oriented vertically like this. And I'm trying to see, the bowing, I want to say, is on this side of it, just on the bottom. You think you'll be able to sand this off?
I won't have any issues sanding that off, I don't think. Yeah. If I really had to, I could machine it on the very slow. But that's an easy fix. They also, this process, different than any other, holds a lot of heat, and the cool down is often longer than the print itself. And I might have pulled this out 2 hours early, which might have contributed to its, I did pull it out 2 hours early. It's not an alleged act. And it was warm, not hot, but warm.
A lot of that's knowing your model.
Yeah.
Knowing the process, a print time, for a large volume, number of layers we're talking about, right? Yeah. It may be, like 6, 8 hours or 10 hours or something like that. We'll need to double that just for the cool down under 100 degrees, and then something. And the longer you wait, the more stable it's going to be and the less likely to warp. All right, so before I continue with my conversation with Adam, I realized we haven't really talked about how the SLS printing process works. And now might be a great time to look at the Formlabs Fuse 1 Plus, take a look inside, and I can walk you through what happens and how this is different than a resin printer or an FDM printer that we've used in the past. Let me pop this door open, and you can take a look on the inside. It's a pretty big machine. I mean, it's definitely more mechanically complex, a lot more moving parts than the printers that we've typically been exposed to. But fundamentally, it's still an additive manufacturing process. It's still generating a 3D object by slicing it digitally into layers and then assembling those layers one at a time. The material it's using to make those layers is of course different. It's not melted plastic, it's not a cured resin, it's a fuse sintered powder. And that powder lives here on the side of the machine, in the hopper. So we have it loaded up with a bunch of powder. We have like about 5-6 kilograms in there. And I'm gonna take open what's called the build chamber. Take this whole unit out. Now, on a printer that you might be familiar with, you might have a build plate, like a sheet of aluminum, or a resin printer, you might have a big metal block. This is kind of that equivalent of that build plate or that build platform. This is the dimensions of the biggest object we can build. So on the X and Y axis, it's about 16.5 centimeters by 16.5 centimeters, or 6.5 inches square. And then the Z height, how tall we can build an object, is about 295 millimeters. So almost 30 centimeters, almost a foot tall in terms of the size of the object, which is sizable. You can build hand prop size things for sure, not helmets. But interestingly, we're using all of the volume, or a lot more of the actual volume here. Now, the way it lays down those layers of powder is also interesting. When we start off, there's no powder on the build platform. We load this whole unit up into the machine, plug in its cable so it knows it's inside, and we start a print. We use the slicer software, we send it into the machine, and it's gonna begin a preheating and priming process. For each layer though, it needs to lay down a layer of powder. And to do that, it's a mechanical process. I'm gonna show you the motors that it uses. It has what's called a dozer on the right side that flips in a predetermined amount of powder from the hopper. And then using a roller, they call the recoder, it actually spreads that layer of powder evenly, rolls it across the top of the build platform. A laser sits inside the top of this machine. It's a 30-watt laser. It bounces through a series of mirrors, and kind of like what Formlabs did with the first, Form SLA printers, it then uses that laser precisely to draw that cross-section, to fuse and sinter that cross-section of nylon powder for that layer. After the layer is done, which can range anywhere from 20 seconds to a minute long, depending on the complexity of the surface area of that cross-section, it then lowers the build platform. So in here, the system actually lowers it by a determined layer height. The Z height is 110 microns, so about 0.04 inches. When we print on FDM, for example, we're printing at typically 0.2 millimeters, so 200 microns. So this is almost half the thickness of that. If we're printing resin, we're typically printing at 50 microns. So this is about twice the thickness of a standard resin print per layer, with different print qualities because it's a fused powder, not a cured resin, not melted plastic, as you can see in the prints that we're gonna look at. So it lowers that build platform, and then layer by layer, up to 2,670 or so layers, it can then start making the object. In our print experience so far, we're not filling out the entire volume of the chamber. When we first went into this, we thought that it would be better to optimize by putting tall objects and wait till we had enough 3D models to fill up the whole volume. We're finding that what's more important is to pack in the density of whatever we're putting in into how many layers. We want the fewest number of layers possible with the highest number and the large number of objects we can pack in, so that we're not wasting powder. So that when we go to reclaim the powder and we mix in 30% fresh powder, we're being consistent with how much we're actually using. So what we're finding is that prints that are somewhere in the realm of thousands to 1,500 layers takes about 12 hours, 9 to 12 hours of print time. That's done at a pretty high temperature. In fact, the whole system here is under pretty high temperature. There's a temperature sensor, an IR sensor at the top to make sure it's consistent. It's why we had to do that calibration with the technician, Jason, when he came to help first set this up for us. Is variance in temperature can really affect the quality of the prints, whether it's warping, whether it's artifacts, or rigidity, or dimensional accuracy. And not only do you have to wait till the print's done, which is the fusing of each layer, the rolling, the lowering, but after the print's done, after that, however many hours, we also have to wait for this entire chamber to cool. The system will know through its temperature sensor whether it's cooled to about 100 degrees Celsius, which is still pretty hot. At that point, you can move this chamber over to the sift and then get ready to start a new print, but you're not going to want to unpack all those prints until the parts have sufficiently cooled, until the armor, until the other powder around your prints are stable, so that you're gonna have the best dimensional accuracy and the best rigidity of those prints. And that usually takes about double the time of a print. So for a 10-hour print, we're actually waiting almost a full day for the print and then the cooling time 24 hours later before we start freeing the parts up. And that's the biggest thing we have to learn with so far, is that extra cooling time, what our workflow is like. If we have files that we want to slice and start on a printer, we want to start that early in the day so we can get that process done. Maybe if we're lucky, by the end of the day, we can get it to 100 degrees, cool it, and start another print. But really, this is about a 24-hour work cycle time for us for the type of iteration we're doing here in Adam's shop. We'll have a lot more to talk about in terms of the maintenance and the operations of this machine. We're adding labels for ways to optimize our interaction, our workflow with it. But let's head back to the table and take a look at the detail on those prints. In terms of aesthetic fidelity, though, I've printed a lot of things that I have in my folders that we printed in resin. I was so curious to do something in resin versus with SLS.
Just to compare.
Just to compare.
And
now,
this is resin, that's SLS.
That's right. Resin is printed on the Form 4L,
right,
and that's at 50 micron height. The fuse is locked in at 110 microns, so a little bit double the layer lines. And it's interesting, the finish, what the powder, the kind of nylon textured finish brings to it, while still retaining, I think, a lot of that filigree detail, even at twice the layer height.
Yeah, given that it's half the resolution effectively, it does not look like half the detail. It looks like about 10% less detail.
Yeah. And I don't see layer lines.
No.
It's
I have caught layer lines here and there. It depends on, again, always as it does, it depends on orientation. And you did some spacesuit connects, which were highly round, and round stuff is tricky with the orientation because you don't want to make it too flat. But you also don't want upright shows a lot. You get to see those line layers nice and clearly on that kind of curve.
This is where I'm going to get more practice locking in orientation, whether it's 45 degrees, and then getting another piece parallel to it, not parallel to another plane.
But literally, I don't think we've had any failed prints here. We've had some things we've tried that didn't work, but the other thing is that, printers for a long time have had a very high quality control issue in terms of putting out 5 great prints and 1 crap one. First of all, I'm not seeing that for the most part across the board of processes, but this one, like every time we have a print, it's like Christmas scrubbing it out.
And it's knowing your model. This little face hugger here, I know that it's going to be extra delicate at the joints where the fingers are, but I'm also often surprised, adding just a little bit of dimensionality, like where the tail is, nylon quickly becomes really rigid, really strong.
Yeah.
It doesn't take an extra diameter to make it a super solid thing. Have you done tapping and machining on parts?
I just did. I just did a mechanical part in which I tapped in some helicoil threaded inserts into the nylon, and it took beautifully and screwed in really nice and rigidly. I was delighted with how it felt. I love nylon for its stability. I think this might be one of the more archival printing processes. Plastics in general, not the most archival in terms of the span of hundreds of years, but this feels to me like the closest thing to that kind of quality.
And I'll be interested as you try to make your pop replicas, what finishing aesthetically looks like.
Yeah.
I did do on the same model.
Oh, you did some painting?
Some painting. And so here, just paint tests on both a nylon and the resin, the same prints.
Same technique too,
Same
yes?
technique.
Right.
So, a couple coats of black primer, some rattle can spray, a little bit of rub and buff, and then some
A little tiny Molto marker.
I
shiny.
have the mirror finish
Yeah.
stuff, and paint flows on resin still a lot better. Yeah, I think paint sits on resin. Oil washes. When you're rubbing stuff off, it doesn't rub off nylon. Nylon, maybe it's a little porous. It's eating the paint a little more.
Yeah.
I think I'm liking the visual finish of paint on the resin parts more right now.
That is a really
it'll be a learning process.
interesting note. Yeah, totally. And it may be that you do more clear coats before or other stuff to kind of get those results. I want to talk to the first few comments, and a real discussion was had in our section about the material safety.
Yep.
Working with the nylon powder, which is a particulate of a very fine size. And that has all the natural hazards of a particulate, like cornstarch or flour. Powders can cause fires. We tested that on Mythbusters with the coffee dairy creamer, one of the scariest things I've ever seen. But besides that, the powder itself isn't carcinogenic. It is not toxic. It's not great to breathe particulate. We totally agree. Sorry for hitting my mic. We totally agree with the comments, and we feel like we actually I want to point out, I downloaded the material safety data sheet, which basically just says, if you're going to be exposed to the powder, wear a respirator. But I work with materials like Cabosil, which is a fiberglass thickener for fiberglass resin. And in special effects shops, we always called it Deathacil because that stuff is ridiculously carcinogenic. It floats in the air. It's awful. I hate using it. I almost never do. This powder is fundamentally different in terms of that presented danger. And we promise if we're doing like a ton of cycling and stuff like that, we're totally going to be wearing masks.
We have respirators. They're attached to the machines now. What we're finding, the glove box mode where we are not exposed to it.
Yeah, it's a fume hood, so all the air is moving away from you.
Yep, and in the SIF, that vacuum is pretty good to pull that. We will modify the gloves so that we are better, more happy using.
That's the thing. I would like
systems.
a different glove, maybe even just for one of the gloves in the glove box, in the bead blaster.
Yeah, and that's part and parcel of how we're integrating this machine into the process here, how we're learning about the workflow, how we're optimizing it for both safety and efficiency and for usability.
Cannot thank you guys enough for the comments, especially those of you who've worked with Fuse machines. There was some little hints in there that I just love that were clearly the result of massive disasters somebody had experienced. All that kind of stuff is really, really welcome.
Yeah, and I know you have a long list of parts that we're sending to this for our next 100 hours. We'll probably do another check-in. But if people out there have projects, have things that they would like to see printed, please post them.
I'm also curious if there are stuff that, experts in 3D printing have of stuff nylon does better than anything else, stuff FDM does better than anything else. I'm always curious about that sort of comparison because for mission-specific jobs, I'm sure people have done some real running these machines through their paces.
We're going to be printing your kits in both nylon and Tough 2000 so you can mix and match and find the right ones for those builds.
I love this printer. I'm so delighted by we've brought processes into the shop before that we had ambitions for that turned out to resist our affection. This is not that case.
No tea will be spilled.
No.
All right, thanks everyone for watching, and we'll be back with more updates about this printer later and see these prints in future projects.
Yes, more replication soon. Thanks, guys.
Thank you guys so much for watching that video. I would be remiss if I didn't tell you we have some excellent merch. We have a 5-pack of demerit badges for sale right now at tested/store.com. We've got the I hung it off of level demerit badge, the I built the chair backwards demerit badge, the I hit my thumb with a hammer demerit badge. We've got the stapler in my finger demerit badge, and my favorite, I stuck the duct tape to itself demerit badge. Get yours now, tested/store.store. Tested-store. Tested. It's right here. There. Just click there.